let's get straight to part B. Okay, in part B, we're told f of x is a function with x an element of R. We're given two other functions, g of x and h of x, and we're asked to show if I add g of x with h of x, I'll get f of x. As it's to show that, I'm going to start on the left-hand side and hope that I end up on the right-hand side. I'm going to use colors here so you can see it a bit more clearly. I'm going to do g of x plus h of x. Okay, so what was g of x? G of x was f of x plus f of minus x divided by 2, and h of x was f of x minus f of minus x divided by 2. Those two guys have a common denominator of 2, so I can write them all over the same denominator. Okay, and if you notice here, I can actually cancel out this with that. I've got plus f of minus x and minus f of minus x. That leaves me left with 2f of x divided by 2, which leaves me with f of x. So I started on the left and I ended up on the right. Okay, that's BI. We look at the next one and we can see that we have the command term hence show. Hence is like hence is their way of telling you that they're trying to guide you towards the right answer, right? So they're saying, using what you previously did, move one step forward. So we're told that f of x can be written as the sum. What does sum mean? Sum means added together of two functions, okay? And one that's even and one that's odd. So we have just written f of x as the sum of two functions. So if you logic that out, one of those must be the even functions and one of them must be the odd functions. So let's have a look which one it can be. So let's have a look at g of x. Let's try and see if it's odd or even. So I'm going to start in the same way that I always start when I want to see if something's odd or even, which is I replace x with minus x in the formula. And that gives me f of minus x, this is all coming from here, plus f of, now in this case I had a minus, so it would be minus minus x, there's a double minus there. Okay, divided by 2. So that leaves me with f of minus x plus f of x divided by 2. My goal is that my last step is in terms of g of x, either g of plus x for even or g of minus x for odd. If I rewrite this the other way around, I can see this is exactly the same as g of x that I started with, right? If I look at the formula for g of x, it's f of x plus f of minus x divided by 2. Well, that's exactly what I've got. So I can conclude here that g of minus x is equal to g of x. So g should be what? Should it be odd or should it be even? Should be even. I'm going to repeat this process with h of minus x. But logically speaking, if they're telling you that it's the sum of two functions, an even and an odd, I know this one's even, I'm going to imagine that h should be odd, but we're going to prove it anyway. Okay, so if I put in a minus x wherever I used to have an x, I'm going to have a minus x here. Oh, I'm going to have there was already a minus there, but I'm going to have a double minus there, and divided by 2. So that's f of minus x minus f of x divided by 2. So I'm going to try and make it look like this so I can be in terms of h. So I'm going to put the minus f of x first, plus f of minus x divided by 2. You can see that the signs are different. So I'm going to factor out that minus so that I can rewrite it in terms of h of x. So I can see that h of minus x is equal to minus h of x, which means this one is the odd function. So you've shown that g of x plus f of x summed together will equal to f. And in this case, this one is the even function, g, and this one is the odd function. So that wraps up part B. We're going to deal with part C in the next video. Keep watching.